Okay, so this week we're going to look at a few things. We're going to start off with what's called the factor theorem. And this section gets into a little bit of long division. Okay, so if you've done long division before with numbers, or you've done it with polynomials, it's pretty much the same thing we're going to look at today. All right, so remember that if something is a root, okay, or a zero to an equation, that means it's the number you can plug in for x, and you get 0 for y. Okay, and you can read that statement as it is a biconditional. If you plug in 0, if a number is a root, then when you plug it in, you get 0 for y. Or you can say, if you plug in a number and get 0 for y, then it is a root. So it's an if-then statement. You can read either way. That's what IFF means. Also, if you plug in a number and get 0 for x, or get 0 for y, that also means it crosses the x-axis at that spot. And what's that called? Where something crosses the x-axis? Yep.
Intercept.
It's an x-intercept. Okay, so we're going to use long division, okay, to find roots. But the first thing I'm going to show you is an example with just numbers. Okay, just basic numbers. So let's say I wanted you to factor the number 12. That means to write 12 as a product of two things. Now, if I tell you that 3 is a factor, 3 is one of the factors of 12. What could you do with the 12 and the 3 to figure out nothing? Divide. Okay. So basically, if I tell you 3 is a factor, that means 3 times something is 12. And then if you take the 12 and divide by the number you know is a factor, you get the other factor. So that's the whole key. If you know something's a factor and you divide by it, you get you get the other factor. Now, does anybody remember what you call that when you divide two things, the answer that you get? When you add, it's the sum. The quotient. It's the quotient. Now, when you divide and something is a factor, what's the remainder when you divide 12 by 3?
4.
Not the quotient, the remainder.
No, 0.
0. So what about if you divide 12 by 6? What's the remainder?
0.
0. So that means 6 is also a factor of 12. But what if you divide 12 by 10? What's the remainder?
2.
2. You've got a remainder, which means that 10 doesn't go into 12, which means 10 is not a factor of 12. Okay, so when you divide something and it's a factor, you're hoping for remainder 0. That's what I just said. And that's, again, the same thing I just said. So if you divide two things and get a remainder of 0, then B is a factor of A. Think of like 20 divided by 4. You don't get a remainder when you do that? That means 4 is a factor of 20. What's the other factor? Well, if you do the arithmetic, 20 divided by 4, whatever you get, that's the other factor. Okay, so the reason why you want to factor something is that makes it easier to find the roots. It makes it easier to find the numbers you plug in for x and get 0 for y. Okay, and that's why you do factoring in Algebra 1. It makes it easier to solve the equation. So now we're going to look at the exact same thing we just did, except now we're going to try it with a polynomial. And we'll go through all the steps. If you don't remember the steps for long division, what I'll do is I'll kind of show you a step, and then I'll do the step in a problem. Okay, so there's going to be about five steps under the division. So if you want to leave room for them, you can, or however you want to write them down. And then off to the side, I'll do the problem. The first thing is, whenever you're doing division, you've got to make sure you have every term. Okay? If your highest exponent is a 3, then you need to have the squared term, the linear term, and the constant. Am I missing anything here?
Squared term.
I'm missing the squared term. So it says, fill in 0. If you're missing a term, fill in a 0. So before I even do anything, I'm just going to rewrite the problem. X minus 3. Put x cubed. Fill in 0 for x squared. Minus 8x plus 3.
Is that 8?
Yeah, that's an 8.
Sorry, I don't
No,
have
the
glasses on.
pen is, it's a little weird. Alright, so that's step 1. Fill in any zeros you're missing. Step 2.
I feel like you don't bring your glasses on purpose. Do you not bring your glasses on purpose?
Take the first term of the divisor, which is x, and divide it into the first term of the dividend. So if you're trying to think, well, what's the calculation you're actually doing? It's this. X cubed divided by x. Yep, which would be x squared. Just put that answer up above. It doesn't matter where you put it. You don't have to line it up anywhere special at this point. Just put it up above. Okay. Any question on that? So divide the first term of the divisor into the first term of the dividend. Now, multiply the answer that we just got in step 2, x squared, back out to each term. And this is where you're going to have to line things up in the right columns. So what's x squared times x? X cubed. And what's x squared times negative 3? Yeah. You notice the way I wrote it? The squared terms are in the same column. Cube terms in the same column. Okay, that's step 3. Step 4, subtract. So you're going to subtract what we just did in the last step. So some people do it different ways. Some people just change the signs. I usually go like this. Draw a line, and now I'm going to subtract. So Michael, what's x cubed minus x cubed? Yeah, and if you do this right, that should happen every time. Ezekiel, what's 0x squared minus 3x squared?
3x squared.
Good, 3x squared. So 0 minus 3x squared. And now when you're doing long division, what's your last step before you do the cycle again?
To take the other numbers down.
Yeah, bring down. So now bring down the next term. So bring down your minus 8x. And we repeat this process until we're done. Okay, how do you know if you're done? Well, either you get a remainder of 0, and then you're done, or the exponent here is smaller than the exponent here. Now, there's no exponent on x, so what number is always there if there isn't one?
1.
It's a 1. So we started with a 3 on the inside and a 1 on the outside. Now we have a 2. We're going to keep going till that number I circled is less than 1. Or we get a remainder of 0, and then we're done. Okay, so now repeat it. Take the first term of your divisor and divide by the first term of your dividend. So now it's 3x squared divided by x.
3x minus 8x.
3x.
Yep. So yeah, it would just be 3x. Now multiply the 3x back out. What's 3x times x?
3x squared.
3x squared. And what's 3x times negative 3?
Negative 9x.
Negative 9x. And now what do we do with those columns? Subtract. So again, I put the minus on the outside to remember I'm subtracting that whole thing. 3x squared minus 3x squared. What happens there? About, yeah? What's going to happen there?
Wait, I'm sorry, what?
3x squared minus 3x squared.
0.
That's gone. And Josie, negative 8x minus 9x.
Oh, x.
Yeah, just x. Now, what's the exponent on the x?
1.
It's a 1. So now we've got an exponent of a 1. The original problem had an exponent of a 1. We got to go one more step, and this is the last time, because then it's going to be smaller than the 1. So it always drops each time you do it. 3, 2, 1. Bring down my 3. Now you're going to divide x into x. What's x divided by x?
1.
1. Now if all you wanted was the quotient, you're done. X squared plus 3x plus 1, that's the quotient. If we continue, now we're figuring out the remainder, if there is one. AJ, what's 1 times x? And 1 times negative 3? Negative 3. And be careful, don't look at it too quick and say remainder 0. X minus x, but what's 3 minus 3? 6. So that's your remainder. Okay, so a couple ways you could write your answer. You could put the quotient and scroll back up to what we had. X squared plus 3x plus 1. Remainder 6. Okay. Any question on that?
So it's all just one quotient?
Yep, that's all one quotient.
No, I mean, like, that's all the steps for that one.
That's all the steps to that one, yep. Now there's 2 ways you can write your answer. That's one way. Or, let's look at something with numbers, and I'll show you the other way. Let's look at 15 divided by 6. What's the quotient when you divide 15 by 6? 2.
For the remainder, 3.
And what's the remainder? 3. So you could write the answer as 2 remainder 3. Or another way to write 15 divided by 6, you learned way back, you take your quotient plus your remainder over your divisor. 2 plus 3/6, or as a mixed number, 2 and 3/6. 2 and 3/6, which is just 2.5. So you can take your quotient plus your remainder over your divisor. Okay. Any questions on why 15 divided by 6 is 2 and 3/6 or 2.5? You can do exactly the same thing with a polynomial. You can write your answer as quotient, x squared plus 3x plus 1, plus your remainder, which was, how much was the remainder?
6.
I think it was positive 6, wasn't it?
Oh, yeah, it was
Positive 6. So quotient plus remainder over my divisor, which was x minus 3. The way that I just circled and the way that I put a box around, it's the same thing. Quotient plus remainder over divisor. When you do this with numbers, you can actually simplify. Like 3/6 simplifies to a half. When you do it with a polynomial, there's nothing to simplify. Okay? The advantage of the second way is you could type this in on your calculator. you could type in the original problem on your calculator, graph them, and see if they look the same. If they do, then you did it correct. Okay. Graph the original, graph what I just circled. So it's a good way, if you want to double check your answer, you can. Okay, any questions on that? All right, that's another long division, which I'm going to hold off on for now. If we have time, we'll come back to it. All right, so this is a sentence that it seems kind of confusing when you look at it, but if I put in numbers for everything, it'll make it a lot easier. Let's say this is 12, and this is 8. So what this is saying is if you divide 12 by 8, you're going to get a quotient and a remainder, and it's going to work in this formula. Okay? What's the quotient when you divide 12 by 8? 1. What's the remainder?
4.
4. So to try to make it simpler, just pretend like you have the numbers 12, 8, 1, and 4, and see if they work in this formula. F of x is 12 equals h of x. That's h of x is what you divided by. What did I divide 12 by?
8.
8 times q. That's my quotient. What was my quotient?
1. I mean 4.
Quotient
No,
was
1.
1. Plus my remainder. What was my remainder?
4.
4. What's 8 times 1?
8.
And then 8 plus 4?
12.
Yeah. So this is how you check your problems when you do long division in like grade school. You take your quotient times your denominator and add your remainder. If you get back what you started with, then you did the long division correctly. All I'm saying here is that exact same idea applies with polynomials. If you take what you divide by, times your quotient, and add your remainder, that's another way, if you had time, you could check your answer. That's all. I'm not going to do anything else with that. Most of the time, you really don't have that much extra time to check your answer, unless you're using a graphing calculator. So, the remainder theorem. Sometimes you're doing a problem, and the only thing you want to know is the remainder. That's it. It's the only thing you want to get. Does anyone remember what I said earlier about the remainder and when you divide by something that's a factor? It's 0. So if you can quickly find the remainder of something, and you know that it comes out to 0, then that shows what you're dividing by is a factor. So sometimes that's all you want to do, is quickly just get the remainder. Don't worry about anything else. So, this theorem that I'm going to give you, it only works in a very specific situation. If you have some polynomial in the top, okay, that's f of x, and the bottom is x minus, and you have something in that box, that's the only kind of problem this is going to work for. If your denominator was x squared minus something, nope, this theorem doesn't work. You have to be dividing by something very simple. And by simple, it has to be an x minus and then a number in the bottom. And I'll come right back to that. This is a problem where you could use what I'm showing you. If you're going to divide by that, this theorem applies. It has to be x minus a number. So, the way you can figure out what the remainder is without doing all the work out is take whatever comes after the minus sign. take whatever is right there and plug it into your original function. That's a trick that'll just give you the remainder. Take the number after the minus sign, plug it into your original function, and calculate the answer. And that will be the remainder. Okay, I'm not really going to go through the proof why that's true, but it works. Okay. All right, let's try it. Okay, we'll try it twice. The first one, I'm going to do f of x divided by h of x. And then we'll come back after and do f of x divided by g of x. And remember, the goal here isn't to find the quotient. You don't have to do the whole long division. All I want to know is the remainder. That's it. Okay, so let's do f of x divided by h of x. And I'm going to find the remainder. So, is what I'm dividing by, in this case h of x, is it of the form x minus a number?
Yeah.
Yes, it's x minus 3. So take the number that's after the 3, after the minus sign, take the 3, and plug 3 into your numerator. Okay, so that's it. Just plug 3 in for f, and we have to figure out what it comes out to.
So it would be -3, just 3.
It would not be the -3, it's just the 3. Okay? And I tried to be very careful when I circled it to show you the minus sign is not included. It's just what comes after the minus sign. Alright, so when we do that out, we're going to get 3 cubed minus 2 times 3 squared plus 3 minus 5. 3 cubed is 27. What's 3 squared? 9 times 2? Negative 18. Plus 3 minus 5. Okay, does anybody have a calculator and did that out? No? Just do it real quick. 27 minus 18 plus 3 minus 5. So we get a remainder of 7. So because we get a remainder that's not 0, what does that mean about h of x? It's not a factor of what? Exactly. Because it didn't go in evenly, what you divided by is not a factor. So if you were trying to factor f of x, h of x is not the way to do it. It doesn't work. Okay, let's try the next one, g of x. And again, I'm just going to calculate the remainder. Is g of x in the form x minus a number? No. But could it be?
Yeah.
How could you make it x minus a number? Yep, Ezekiel?
X minus -1.
Exactly. So it does work for plus, but you have to think of it this way. That's what comes after the minus sign. -1. Okay? So now, in the original, what number would I plug into function f? -1. And then see what we get. This should be a little quicker to do. What's -1 cubed? Yep, -1. What's -1 squared? 1 times 2? 2. Minus 2. And we're plugging in 1. Minus 5.
Wouldn't it be negative? Yeah, would it be negative?
Yes, -1, thank you. -1 minus 2 is going to give you -3. Minus 1 is -4. minus 5 is negative 9. So I didn't get a remainder that's 0, so what does that mean about g of x? It's not a factor of, exactly. G of x is not a factor of f of x. So any questions on how you can quickly find the remainder if you're dividing by something that's x minus a number? Technically, you can do x plus a number as well, but x minus a number. Okay, and that's called the remainder theorem. Okay, and the factor theorem. It's pretty much the same idea that we just went through with the remainder theorem, except it's the remainder theorem when you always get a remainder of 0. That's the factor theorem. So the only way that x minus c could ever be a factor, bless you, is if the number after the minus sign basically results in a remainder of 0. Okay, that's what that's saying. The only way x minus c would ever be a factor is if c is a root. Okay, so those two things mean the same thing. If 3, just as an example, if 3 is a 0, or 3 is a root, in other words, it's a number I plug in for x, and I get 0 for y. If 3 is a root, then x minus the number I just said is a factor. Okay, and that idea is important. Okay. If you know a number is a root, then x minus that number is a factor. Always. So what if I said to you, I'm thinking of a polynomial and 5 is a root? What would have to be a factor? Well, if 5 is a root or 5 is a 0, what would be a factor? It has to have an x in it.
Oh no.
So if c is a root, x minus c is a factor. What if 5 is a root?
X minus 5.
X minus 5.
Oh, okay.
What if I'm thinking of a polynomial in my head where 2 is a root?
X minus 2.
X minus 2 would have to be one of its factors. Okay? All right. So I want to use the factor theorem to show that x plus 2 is a factor of what I just wrote below. Now I could do all the division out, but all I have to do to show something is a factor is show what? That the remainder is what? 0. And that's exactly what the factor theorem means. So let's use the remainder theorem, and we're going to hope that we get a remainder of 0. All right, so if we call this f of x, and that h of x, what number am I going to use to calculate the remainder? What's the number that's going to be plugged in here?
Negative 2.
-2. And what am I going to plug that into?
X.
X in which equation?
H.
F or H?
H.
H, exactly. And if x plus 2 is going to be a factor, what are we hoping to get for a remainder?
0.
We're hoping to get 0. Okay, let's go through it. -2 cubed. What does that give me? Careful.
Negative 8.
-8. -2 squared gives me 4 times 5?
20.
20. Caitlin, what's 5 times -2? You get -10. -2. David, what's -8 plus 20?
12.
Yep, 12. And now I think we can tell what's 12 minus 10? 2 minus 2 more? 0. And what is that 0? That's my remainder. And what does it mean if I get a remainder of 0?
It's big.
That is a factor. Yep. And what number did we just prove is a 0? Doing the remainder theorem? What's the number we plugged in? Negative 2. So if you were to draw this, it would cross the x-axis at negative 2. Maybe it would cross in other places, but it would at least cross in that one spot. So any question on the idea between a root and a factor? I'll show you another one that kind of connects them in a second. Okay, so here's kind of some equivalent statements that all mean the same thing. Okay, so suppose you have a number, and I've just been calling it C, and you plug it into this equation and you get 0. So it's a number that you can plug in for x and you get 0 for y. That means it is a 0. That's what you call it. It's a 0 of the equation. And what's another word for 0? I've kind of been using these two words interchangeably. Root, same thing. If you plug C in and get 0 for y, it's also called a root. What did we say graphically? C would be where the graph crosses which axis? The x. And what does that mean? If something crosses the x-axis, it's an x-intercept. That's the last one I wrote. But the fourth one is particularly important. If C is a root, where C is a 0, x minus it is a factor. And graphically, I guess if you're graphing, the last one is important. Okay, so let's say I had some polynomial and I plug in the number 5 for x, and it gives me 0 for y. That means 5 is a 0. That means 5 is a root. That means the graph crosses the x-axis at 5. That means x minus 5 is a factor. Okay, those all mean the same thing. Any questions on those? So now I want to kind of use one of these facts from the other page. I'll put them back up to figure this out. I'm thinking of a polynomial, and I'm telling you that the roots are negative 2, 1, and 3. That's the same thing as telling you the zeros are negative 2, 1, and 3. That means the polynomial I'm thinking of crosses the x-axis at negative 2, 1, and 3. But it means one more thing. If negative 2 is a 0, what else does that mean?
2.
So negative 2 is a 0, it means it's a root, it means it's an x-intercept. But there's one more way you can say something equivalent, and that's what's going to help us. So if negative 2 is a root, what must be a factor of what I'm thinking of? Well, what does it say? If C is a root, x minus C is a factor.
X minus 2.
So, careful. If negative 2 is a root, then what would be a factor?
X plus 2.
Exactly. That's one of them. What about if 1 is a root?
X minus 1.
X minus 1 would be a factor,
X minus 3.
and x minus 3 would be a factor. Now, just distribute it out, and then we'll do it again and see what we get. So we get x squared minus x plus 2x. What's minus x plus 2x? X, and then 2 times negative 1? Negative 2. So now just distribute one more time. X squared times x. X cubed. X times x. X squared. X times negative 2. Negative 2x.
Sorry.
Negative 3 times x squared. That's going to be the last one.
Okay, yeah.
Negative 3 times x squared.
Maybe
Negative 3 times x. And then negative 3 times 2, Josie just said, plus 6. So we've got x cubed, x squared minus 3x squared. Negative 2x squared. Negative 2x minus 3x. Negative 5x. And plus 6. Let's graph what we just created. X cubed. If you don't have your calculator, you can just watch it. Minus 5x plus 6. When I hit graph, what are going to be the 3 spots that it crosses the x-axis?
-2, 1, and 3.
Because of how we created it, it should be negative 2, 1, and 3. Let's hit graph and see if that's what we got. So there's negative 2, there's 1, there's 3. Exactly what we wanted. Any question on that? So that's the kind of problem you might see on a test. It'll say find a polynomial where it crosses the x-axis at these spots, and that's how you do it. Any questions on that? All right. All right, so let's finish up with this one, and then if people want me to go back and do the long division one, I can. But if people think they're fine with long division, we can skip it. All right, factor by grouping. That means you usually have 4 terms, and you write them down so the first 2 and the last 2 have something in common. If they don't, rearrange them so they do. And if you say, well, what if that doesn't work? No matter how you rearrange them, if I tell you to do factor by grouping, it will. So I think the way I have them arranged, the first 2 have something in common, so do the last 2. Does anyone see what the first 2 have in common?
X squared.
Yep. So what we're going to do is factor that out just from the first 2. What would you be left with inside parentheses?
X plus 2.
X plus 2. Now the whole goal is when you factor out whatever the last 2 have in common, you get x plus 2 again.
Yep.
If that doesn't work, then you can't use factor by grouping.
Negative 4.
Yep. If you factor out a negative 4,
X plus 2.
you're left with x, because negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. Any question on the first step? Now, look at what I put a box around there and there. What does each box have in common now?
V equals 0.
They each have an x plus 2. Okay, so now you're going to factor that out. If you take x plus 2 out of the first box, what's the only thing left?
X squared minus 4.
X squared, yep. And if you take it out of the second box, you're left with a minus and a 4. And now we're going to do what Evan just said. You have 2 factors. You set each one of them equal to 0. X plus 2 equals 0. x squared minus 4 equals 0. What do you get when you solve the first one?
-2.
-2. Very good. And now the second one, you would add 4 to each side.
-2.
So x squared equals 4. And then how do you get rid of squaring?
Square root.
Square root.
Square root. So what's the square root of 4?
2.
Plus or minus.
Plus or exactly, plus or minus.
Match.
So what are the three answers here?
-2 plus or minus 2.
-2, -2, plus 2. So not all your answers have to be different. Okay? Two of the answers are the same. -2, -2, plus 2. But there's still three answers. They're just not all unique. Okay? We call that -2 a double root because it occurs twice. When you look at a graph, let me graph that so you can see what a double root looks like. X cubed plus 2x squared. Oops. X cubed. So how many times is this one going to cross the x-axis? Well, what are the spots it's going to cross again?
-2.
-2, -2.
So 2 times.
Yeah, so it's only going to cross 2 times. And if I can type it in, I might show you what it looks like. 2x squared minus 4x minus 8. So -2, -2, and +2. When there's a double root, what it does so it only crosses twice is it kind of comes up, it just touches the number, and then bounces away from it. Because if it actually came up and crossed through it, then it would have to cross back down somewhere. And then it would create another root. Okay, so that's what a double root always looks like. Just touches the graph and bounces away. Okay, so there's your two roots. Okay. And any question on how you would do the roots on a calculator? Can someone just remind me, what do you press?
Let me get back to you.
Trace.
Second, trace, and then which option?
0.
Yeah, the option for zeros.
Okay, we're gonna get that.
Okay, so if you have to do it on the calculator, you pick a point to the left,
All of the lines, do that.
pick a point to the right. So it puts those dotted lines on the screen. You do a guess, and it tells me the root. Okay, so if you can't do it graphically, algebraically, you can always just do it graphically. Does anyone feel uncomfortable with the long division?
Yeah, could you do that one?
Can I do that one?
Yeah.
Yeah, let me put up the homework so for the people that want to start that, they can do that, and then I'll go back to the number. So homework tonight is on 171. 1, 2, 4 through 6, 9. 13, 15, 17, 19, 20, 25, and 32.